we are going to start the robot design in the Fusion 360 software, where we will design the robot and take into the Gazebo simulation. So make sure that you watch the video till the very end and subscribe to the channel, and also install the Fusion 360 software on your Windows system. I will give the link in the description. Make sure that you follow the steps and install the Fusion 360 software. So let's get into the video. So let's open the Fusion 360 software. Fusion is opened. Now I will start the designing here. Before designing, some important points are there. Whenever you design in Fusion 360, especially for the ROS to take the robot into the Gazebo environment, make sure that the Z axis is in the upper side and the X axis is to the right side. So that's how it should be. You can see here on the top right side, the Z side should be in the up and X should be in the right direction, because whenever we do the simulation, the facing of the robot, the front side of the robot is in the X direction and the above side is in the Z. So that's the main reason. So let's draw the sketch here. Before drawing the sketch, we have to select the top side on the axis, because we are going to draw the robot sketch for the base of the robot. So the direction will be to the right side, to the X, and the upper side will be Z. So for that reason we are taking the top view of the robot, so it will become easy to select the plane and draw the sketch, right? So that is to draw the base of the robot. So let's create a sketch. I have selected the plane, then we have to select the rectangle. If you are if you want, you can make this video fast or else make it slow to follow these steps. Okay, then we have to create the rectangle, center rectangle, keep it here 100 mm. Let's make it 150, right? So the width is 150. I'm pressing OK. Okay, and then I have to change the dimension for the width as well. So for that, right clicking here, repeat, sorry, for that select this particular area, and then we have to select sketch dimension, and after this sketch dimension we have to mention the width here. Let's make it 100. Okay, so the width is 100. That's it. So this sketch is created. Now we have to finish this sketch first, and then this sketch is created, right? But we have to make it we have to give it a thickness, right? We have to extrude that particular sketch in the Z direction so that the robot will become somewhat bulky, right? So for that, okay, you can change the axis here. Okay, by the way, for the movement of this, you have to press the left mouse, then the scroll button for panning. So these are some operations you can do using your mouse. Zoom in and zoom out by the scroll button. Okay, again coming back to the extrude part, click on the surface, press E on the keyboard, E letter. I'm pressing E here. Then I can give some values out. Let's take it 10 mm, make it 20 mm. Okay, 20 mm seems fine to me, right? Let's make it 20 mm, or it's 25. Okay, 25 is done. You can see we have extruded the robot base. Okay, so the base of the robot is created, right? Now we will make some more components on the robot. Still we are defining the bodies of the robot, right? You can save the changes here. Okay, we can give it robot underscore mini, or mini, anything you want, you can name it. Okay, and now here we are selecting the plane from the upper side. You have to create the sketch again, because now we will make the lidar sensor on this particular, on the top of it, right? So for the lidar sensor, let's draw a circle of 50 mm, let's say. Okay, let's finish this sketch. Okay, that's really simple. Then select the circle again and then press E to extrude the lidar, right? So we have to extrude the lidar around 30 will be much more, because we have to again make the lidar disk above out of it, because currently we are making the lidar and keep the operation as join. On the right side you can see here, keep the operation join, not new body or any other operation, because we are keeping this particular bulk part of the lidar attached to the robot base link. We will create the separate body of the lidar which rotates. Okay, I will explain that, but just keep it joined, right? So now this is the complete one body itself, not two different bodies. On the left side you can see that it is completely one body. Now we will again make a disk on it by extruding this particular surface. Why this is so? Because for the lidar we have the base and on that we have a disk which rotates, right? Now we have to make a disk which rotates, and that disk will be a completely new body. Okay, so for that now we will select this disk and press E and extrude this part to around 10 mm, let's say. Okay, 10 mm is good, and then press new body. Okay, we have selected new body on the right side to make the disk of the lidar separate, and press OK. That's it. We have created the lidar sensor as well. Okay, now we need the wheels of the robot and the caster wheel. Okay, and one camera as well. So first let's make the wheels, the driving wheels. So the x-axis of the fusion is on the right side this way, so we will create the wheels. So now to create the wheel we will select the side of the robot and then create sketch. Okay, so we have to create this sketch here. First of all, for making the wheel we will create a shaft. So make a small circle here somewhere. Okay, here it is fine. We can keep it, I guess 8 mm will be much more than enough. Okay, we have created circle of 8 mm, but for now you can see that if I select the rim of the circle and left click and drag, it is moving, right? It is not fixed. So to make it fixed we have to select this particular option, sketch dimension. Okay, by selecting the rim and then select the width of the robot. First we will select the width. Okay, and the distance is 14.16. okay, let's make this distance to 15. Okay, and again select the rim and select this particular area and just leave it. So here it says 14, we will again give it, let's say 15, right? And here we will reduce the distance by giving it 14. Okay, now the role of this particular sketch dimension is to make the center of the circle to the width of the robot, the distance of the center of the circle to the width of the robot, and the length of the robot, the borders of it, right? Borders of the bases. So to make the distance accurate and to make the circle fixed, that's the main motive, right? So if I try to move this circle, it is not moving, right? So we have created the circle. Now finish the sketch and again coming back to the extrusion part now. So we have to select this particular area of the circle and then press E again to extrude that particular part and keep the operation as join. Make sure that you check out this to keep it joined so that it will remain in the base of the robot itself. We have to don't create a different body for that, right? And extrude this particular part around 10 mm. or 8 mm, let's say. Okay, 8 mm is fine, right? And press OK. So the shaft is created. Now the wheels are important, but you have to create the shaft on the opposite side as well. You can see here. So to create that, we will just mirror it. We can also create the shaft again by creating these sketching the dimensions, but we will just mirror to save the time, right? So press on the modify, sorry, on create itself, then you will select the mirror option, object type, features, mirror plane. You have to select it, but first select the object. Okay, object is selected, right? The feature, let's say at the front side. Now we have to select the mirror plane. So for that, zoom out so that we can clearly see the plane, right? So the plane is now visible. Just click on the mirror plane itself. If it is not visible, make sure that you zoom out to see it clearly. Select the mirror plane, and now you can see that the part is here mirrored, right? Joint part, that is the shaft. Now press OK. That's it. So we have successfully created the shaft, right? Now let's go to the wheel wala part. So to create the wheel, we have to select the circle surface and press on create sketch. Now we will draw one more circle on the shaft, center of the shaft, that is important, and let's keep it 50 mm will be fine, more than enough. Okay, so the wheel is 50 mm, right? And press OK. That's it. We have created this sketch. Finish it. Now we have to extrude this particular wheel. Okay, for that, press the wheel. Now the shaft area is not selected. You can either select it or not, it depends upon you, but I will select it. Press Ctrl and select the shaft surface as well. Okay, and now press E. We have just selected the outer circle and the inner circle, and I have pressed E to extrude it, right? So we can extrude it by 10 will be more than enough. Yeah, right. Now keep the operation as body, new body, because these are wheels, right? You have to keep them as new body so that we can create joints later, right? And press OK. So the wheels are also created. Now what we will do, we will again mirror that wheel on the other side. So click on the mirror option, features is selected, select the feature, and then the front side, mirror plane selection, zoom out, select the plane, press OK, and once you can check if the wheel is created or not, right? So the wheel is also created, right? Perfect. Now we will go to make the camera, right? So for the camera, it's really simple. We are not going to create any fancy designed camera. You can go for that as well, but the main motive of this particular video is to create a simple robot design and take it into Gazebo and do the URDF wala part. URDF is nothing but Unified Robot Description Format, which we are going to watch in the next video and get those concepts cleared. But for this particular video, we are focusing on the simple design part in Fusion, right? So now select the upper plane from the top, and we will create a camera here on the base itself. Okay, for that, again select rectangle, center rectangle. We will draw a square here of 10 by 10. Yep, that will be great. Okay, now select the square surface and press E, right? And we will give it 10 mm. 10 mm will be more than enough, or else 15. 10 is good. 10. Make sure that this is not getting in between of this lidar boundary, because the lidar rays will be stopped by this particular camera, or the it will not be good, right? Now make the operation as new body. Because it is camera, we will create a different joint for it. Press OK. So the camera is also created. Now only one part is remaining, which is caster wheel, right? So the caster wheel is in the bottom, but you can see here the robot is not aligned above the origin wali line, right? So we have to take this particular wheel on the surface level. So for that we should know how much distance the robot is below the surface. So to calculate it, it's really easy. We will draw here a tangent plane, and we will get a simply plane on the wheel, and we will calculate the distance from that particular plane to the base of the robot. That is, I will explain here. That is from this particular surface to the surface base or bottom of the robot, right? Bottom surface of the robot. So for that we will click on construct and then tangent plane. You have to select the surface of the wheel, this particular, right? Okay, and click OK. We just only want one normal tangent. So the tangent plane is there. Now we have to measure it. So for that, just click on inspect, measure, select the tangent, and the bottom of the robot, right? So what is the distance? It's 14 mm, right? We have got the distance. Now we have to move the robot 14 mm above, and we have to draw the caster wheel as well, which is 14 mm of the extrusion, right? We're going to do that. So just close it. The roll of the tangent was only this much, so delete it, no need of it. Now zoom out. Okay, go in the bodies on the left side, press Ctrl and select all the bodies which are there. Okay, choose the body 5. Okay, select all the bodies and press M to move them, right? So we have pressed M, and here on the right side you can see that X distance, Y distance, Z distance, Z angle, Y angle, Z angle, sorry, X angle, Y angle, Z angle, and then Z distance. Just make it to 14 here, so it will move upside up to 14 mm, right? So we have our robot on the surface, right? You can see that it's on the surface, not below the surface, right? Okay, now the caster wheel part is remaining. So select the bottom plane of the robot and hit on create sketch. We are going to create a simple ball caster. So we will select the circle and draw a circle here of 20 mm. Press enter, finish sketch. Okay, hit on the circle surface, press E. You can watch here the distance of the wheel from the bottom of the surface was 14, right? So we will create 14, and the operation here we will select as new body. Let's keep the caster as a completely different body from it. Hit OK, right? But still the caster wheel is not created because the surface is flat here, and we need a curved surface for the ball caster, and that's possible. We will select the caster circle surface, click on modify, and then we will select fillet option, right? And we can write here it was 14, right? So let's 7. Okay, it's 12, I guess. No, it's 10. Okay, 10 is fine, right? It has become the completely smooth and ball type of structure, right? So that's how it goes. You have created the ball caster. The design is completed. Okay, almost completed. Now we will do one thing. So the bodies are created, right? All these are bodies, but we have to make them into components. Okay, so for that reason we will select bodies on the left side, click right button, right mouse click, and create components from bodies. Just make it, okay? Left click on it. So we have created the components. So each body has became a component now, right? So that was the reason behind that. So we have created the components. Now we will do one thing. We will add joints here. See, the problem here is now each of them is a different component. That is good. But if I drag it, it is moving. We have to make it fix, right? It is moving. See, this camera is also moving. If I take this particular model and put into the Gazebo environment, the robot will just disintegrate. So the wheels will also be not able to join. Sorry. So the wheels will also be not able to rotate because we have not defined the joint, the type of the joint. If you don't know anything about joint, go back in the 50 days of robotics series, you will get it, right? So the main problem is to give the joint, and that's really simple. Okay, so let's start with the simple joints. For that, just select the upper component that we have to join to the base link. Let's call this one as base link. Okay, and we will give joint here. We have selected the lidar to give the joint. So for that we will just get the bottom side of the lidar, it's visible, and press J. Press J to give the joint on your keyboard. I have pressed it. Select the center of the circle like this. It's selected, and make sure that you select the center of the base as well, base lidar, so that it will join. Okay, now come to the right side. The position is good, but we have to give motion here. It's rigid. Fine, so we have given rigid joint here. Similar to the case of the camera, we will give rigid joint here. Okay, so get it outside, get to the bottom of it, select the center, and now whenever we give joint, you can either give the joint on the center or else to the edges of it. So it's a so it is a rectangle, so it's not possible to give it on here or somewhere, because we can only give to the center. As it was circle, we have given the joint of the ladder to the center, but for the rectangles we can give on the center or else on the edges or corners. So we'll give it on the edge. Okay, that's fine, but we will just change the position here. Okay, up to 15 mm, that's it, no problem on that. Okay, so we have given the joint here, but we have just changed the position of it. It's fine, right? Similarly we will do with the caster wheel as well. We will make it rigid. Just first complete the rigid joints, and then we will move to the different type of like revolute joint as well. For the caster wheel, again press J, select the center of the caster wheel, and you can here select the center of the base. Oops. I will again try it. Press J, center of the caster wheel, center of the robot, right? Now we will just move the caster wheel from the center to the front side. Okay, so that's how you give the joints. Okay, now only the wheel joints are remaining. For that we will move the wheel little bit to the outside. It's simply similar. Select the center of the wheel, and then select the center of the shaft. Right now, to rotate the wheel, we have to just change the type of the joint, right? And the type is revolute. That's it. You can see it's moving, it's rotating, right? But just don't give any joint limits here, because we want the wheel to move continuously, so no requirement of the limits. You can press OK. and similarly add the wheel joint here as well. Press J. Okay, so it's revolved, right? So we have done with the joints part as well. So the design is completed. Now just we will change the name of the components. The first component is the base. We will call it as base underscore link, because it is highly important that you name the base as base underscore link in Gazebo or else in ROS, because whenever we manage the URDF it becomes really easy to understand what is the base, and we just name it base underscore link, because in the ROS from the previous distributions the base of the robot is called as base underscore link only, so it becomes easy to manage the frames. Okay, now the component 2 is lidar. So lidar. Component 3 is right wheel. So right underscore wheel, it's left wheel, so we'll write here left underscore wheel. Component 5 is camera, so camera. Component 6 is caster wheel, so caster. Right, so all the components are named precisely. Now we will name the joints. So it is rigid joint 1, which is for the lidar. We will just make it lidar underscore joint. Rigid 2, it's camera joint, you can see there, it's camera underscore joint. How I know this? Because we have given the joints for the respective components. Rigid 3 is caster underscore joint. Revolute 4 is right underscore wheel underscore joint. Revolute 5 is left underscore wheel underscore joint. Okay, so we have named the joints as well. So this was for the design part. Hope you understood the design, and make sure that you follow these steps. If you don't understand any step, watch the video again, make it slow, fast, whatever you think. If you have any further doubts, you can put them in the comment section, or else reach out to me on LinkedIn as well as on Instagram. So we will meet in the next video. We will see about the URDF conversion. This was about the design, but the URDF conversion is also important. Still we need the Fusion software in the next video. So let's meet in the next video. Till then, grow, learn and explore together.